I would like to welcome everybody to this 15th webinar organized by Eijkelkamp North America on CPT. What we're going to talk about today is what cone works for you, to give you some guidance on what is the most appropriate cone for a certain application. I would like to introduce Troy Chips, the CEO of Eijkelkamp North America. Troy, floor is yours.
Thanks, Gerald. I appreciate it. You know, I can't believe it's our 15th webinar already. These webinars are really, you know, we keep saying this, but they're really for you guys. Whatever you would like, if you're looking for more information on a particular topic covering CPT, please let us know. And that's how this webinar came. Is we've had people wonder, you know, do I use a 10 centimeter square cone or a 15 square centimeter cone, or compression versus subtraction? So excited about this webinar. Again, it's our 15th one, and we welcome all of you to this webinar. With that, I would like to turn it back over to Gerald Verbeek, which is our technical advisor for the CPT.
Thanks, Troy. And as Troy already mentioned, the reason for this particular webinar is because the question comes up time and time again: what is the most appropriate cone? And what you see on the screen right now is a very familiar illustration. For those of you that have attended previous webinars, you see on the right-hand side a cone truck. It doesn't have to be a truck. It can be a crawler. It can be any other vehicle to carry the pusher to the side. And then with that pusher, we push a cone into the ground using the rods. And you see in the center of that illustration what you do in that cone. You measure the tip resistance, the pore water pressure, the sleeve friction, and some other stuff. And what I've told you various times, and it's very important, it's a very standardized system. Standardized in the sense that we push it into the ground with a certain speed, and the dimensions of the cone are also very much standardized. And then what you see listed on the left-hand side is what do you need to perform CPT. Obviously, you need a carrier, you need a pusher, then you need this electrical CPT system, the cones, the filters for the pore pressure sensor, potentially modules. And then the question comes up, well, Gerald, on the one hand, you say that it's standardized, but there's a 10-ton pusher or a 20-ton pusher, or sometimes even more than that. There are all kinds of options, and give us some guidance on those options. And the item that I want to focus on today is the cone, because that's really where you have lots of options and what is the most appropriate cone selection for a specific application. Here you see that cone. The nomenclature, you have the tip, you have the friction sleeve, and you have the filter element, and that is the cone. But then when you look at some other pictures of cones, here you see one, then suddenly you start seeing that there is some small differences, because in the cones that are now boxed in red, you see that the filter element is basically missing. We still have this O-ring in between the friction sleeve and the tip, so that the friction sleeve can move freely, but there is no filtering. So apparently there's this option between a cone with a filter element, a piece of cone, or not. Then, of course, there is the issue about the size of the cone. We covered it in the past that as you are having a larger diameter cone towards a 15 centimeter square, you have a more robust cone because it is there's more steel, there's more metal available to make the cone stronger, because the instruments inside the cone still have the same size, and since the diameter is greater, I have more space available to put steel there. But then it's less sensitive. But again, what is the optimum selection? And then finally, of course, the issue that Troy already mentioned, compression versus subtraction. In the compression cone, you have separate load cells for the cone tip and the friction sleeve, whereas in the subtraction cone, we have one load cell that covers the tip resistance, and then a combined load cell for the tip and the sleeve friction, and then obviously to figure out what is the sleeve friction, what is the load on that friction sleeve? You need to subtract the 2, and that's why you get the subtraction cone. So again, a question: compression versus subtraction. What is the right option? The result is sometimes confusion. All see all these options and really don't know what to select. And what I will try to do today is go over those 3 elements: 10 versus 15, piezo cone versus a regular cone, compression versus subtraction, to give you some guidance on what is really the most appropriate cone for your application. And we'll start with the simplest question. That is, piezo cone or not. And the items that you have to keep in mind is that, first of all, when you push the cone, you might as well get as much information as possible. The more information you get, the more you know, the better your interpretation of those results are. And I'll come to that in a second some more. Secondly, pore water pressure gives you an additional option to determine the soil type behavior. Again, more information gives you more better understanding. But in this case, by getting the pore water pressure, you have 2 independent parameters, 2 independent methods to actually figure out what the soil behavior type is. And then finally, the pore pressure information is essential to correct the tip readings. But let's look at those 3 elements one at a time. First of all, when you come to a job site and you start pushing the cone, as you push the cone, you gradually get information on the screen. Now, whether I get only the tip or the sleeve, or also the pore water pressure, it doesn't cost me any more time. It doesn't cost me any more efforts. Okay, you have to saturate the cone, but by and large, it's the same effort to get more information. So you might as well do it with a piezo cone. After all, you then get more information. There's something more important. You see here the charts that I've shown you before for the soil behavior classification. On the left-hand side, you see the graph where on the vertical axis you see the tip resistance, and on the horizontal axis you see the friction ratio, which is the ratio between the sleeve friction and the tip resistance. And you see there a number of areas identified that, as you see in the bottom of the slide, identify what the soil behavior is. Now, a relatively accurate correlation. We've been doing this for a lot of time, but it's just one correlation, and no correlation is perfect. On the right-hand side, you see a similar graph. Again, we put the tip resistance on the vertical axis, but now I get my pore pressure parameter, which is based on the pore pressure that I measure on the horizontal axis. And again, get these areas classified. And if you have a piezo cone, you basically have 2 independent methodologies, 2 independent graphs, where hopefully you get the same answer, but at least you have more information, independently assessed in 2 different ways. So another reason why you want to use a piezo cone. And finally, probably most importantly, if you push a cone in the ground, what you're going to get is that you get a tip resistance by the soil, as indicated by the red arrow. But at the same time, the pore water pressure is acting on the back of the tip, pushing in a way in the opposite direction. And therefore, what is happening is that what you are measuring, sub C, is not really the tip resistance, the corrected tip resistance, the actual tip resistance that is indicated by the red arrow. Because I need to correct something on it that is based on the pore water pressure value. Now, in sand, it is not that essential because the excess or the dynamic pore water pressure is not that much. But in cohesive soils, that correction must be applied. And since you don't know whether you're going to get sand or a cohesive soil, a clay or a silt, it only makes sense that you are using a cone that allows you to make that correction. And to make that correction, you need to know the pore water pressure at the U2 position, and therefore you really need to use a piezo cone. The 3 questions that I have The first one is really simple to answer. Piezo cone or not? No, use a piezo cone. More information, accurate information, and it allows you to correct your data point. So that's simple. Let's then go to the second one, 10 or 15. Well, at first sight, it's again as straightforward as the piezo cone. 15 centimeter square cone is more robust. We already talked about it. So less chances to break it. And let's face it, however much experience you have, however careful you are, at some point you are going to break a cone. You're going to lose it, and therefore the more robust the cone is, the less chance it happens. Therefore, 15 centimeter square cone makes sense. Also, as we talked about quite a bit, 15 centimeter square cone gets you deeper. Robust, I don't need to explain any further. We already talked about it. And then the 15 centimeter square cone is again something that we've talked about in the past. If you are pushing a cone and you have a limited amount of pushing force at the surface, and let's face it, that's always the situation because your pusher has a limited pushing capability. The deepest you can get in a soil is with a oversized cone, in this case a 15 centimeter square cone, which has a diameter of 44 millimeters, 1.75 inches, and then the standard 36 millimeter rods or the 1.44 inch diameter. That gets you the deepest. So both from the sturdiness as well as the fact that you can get deeper with a given amount of pushing force, yeah, you would say 15 centimeter square cone, yeah, done deal. However, as you are increasing your cone diameter, you get less sensitive when it comes to the measurements. Smaller diameter is more sensitive. In a way, you need to look at it kind of like a pencil. If you want to do detail work, you go to a smaller diameter pencil to make something like painting on the left-hand side. If you want to do something with a broad brush, something this way you can see on the right-hand side, yeah, you can use a broader brush, a bigger brush. Well, the same thing here. If you are doing something, if you want to have more sensitive measurements, yeah, it makes sense that you have a more sensitive cone. When do you need those sensitive measurements? In soft soils. So the answer to the question is not as straightforward as a piezo cone or not. There, the answer was straightforward. Piezo cone is the way to go. But in this case, what you need to say is, listen, 15 centimeter square cone has its advantages. Yes, I can go deeper. Yes, it's sturdier. But in soft soils, where I really need to get more sensitive measurements, a 10 centimeter square cone may be more appropriate. So what you see in there is that still the 15 centimeter square cone has a preference, but you see there underneath an exception there. Well, then you already probably figure out the direction that we're going. First one, straightforward, no questions asked. Second one, well, there's an exception. The third one is really the tough one, compression or subtraction. Let's put the main items again in there. Subtraction cone is more robust, just like a 15 centimeter square cone is more robust. So less chance to break the cone, therefore subtraction is a better choice. But it may not be able to measure the sleeve friction accurately. It's not an issue only of sensitivity, and you may not have the correct accuracy. Let's look at those two things again, one at a time. First, let's look more again at the internals of the cone. What you see here on the left-hand side is this cone for compression type. And you see here the load cell for the cone tip. And then you see here this friction sleeves connected to another load cell. And those two load cells work completely independently. The subtraction type cone, load cell for the tip, combined load cell for tip and sleeve. But you see that this internal is much more solid, much more robust, much more sturdy. Now, I know this is simplification, but it gives you a clear idea of what's happening in the bottom part of the cone and why this subtraction type cone is a sturdier design. There's an issue with regards to the accuracy. Let's look again at the soil behavior classification, where you see on the vertical axis the tip resistance and on the horizontal axis the friction ratio, and you see that we show it somewhere between 0 and 8%. It's not that we're only showing one part of the chart. It really goes from between 0 to 100%. The friction ratio is generally a low percentage of a low percentage number. And that's important that we realize that. Because the other thing that we have to realize is that the load cells have to be rated to the values that you can get. And if you look right now at the tip resistance, we show here between 0 and 100 megapascal. That means that load cell is indeed rated then for at least 100 megapascal. We also, what's important is that you have an accuracy for a load cell that is typically somewhere at 0.5% of the full scale output. And in this case, 0.5% of 100 megapascal is 0.5 megapascal. For those of you that are more used to dealing in PSIs and in kips and in tons, don't worry about it. It's right now the principle, and that's why I will only give you the numbers in megapascal. Now, let's take a certain soil, and that you see indicated by that red dot. You see there that the tip resistance is about 20 megapascal, and you see that you have a friction ratio of 2%, which means that the stress on the friction sleeve is 2% of 20 megapascal is 0.4 megapascal. But that 0.4 megapascal is less than the accuracy of the load cell, because that load cell, that combined load cell, has to be rated at least for the tip resistance, which means it's at least 100 megapascal. And that basically means that if you are having a subtraction type cone, you basically may not be able to catch the sleeve friction accurately. And when you are taking measurements, then basically you have to make sure that you can cover and measure the sleeve friction accurately as well. So, what does it mean? Basically, in compression or subtraction type cone, it depends on the soil. Because if you want to make sure that you are getting good values of your sleeve friction, then obviously you need to make sure that you have the cone that can do that, but it obviously is a function of your sleeve friction. Because if you were to have, well, let's go back to this one, if you would have, instead of a 2%, if you had a 5 or 6%, somewhere more here in this part of the chart, then obviously this issue is no longer a major issue. Now, what does it mean in reality? Because I've given you now some of the backgrounds of the reasons of these things. What would I suggest when you start out with a cone or CPT system, what cone to select? Because that's always the question. Find all these different answers, but what does it mean for me personally? Well, let me give you two options. If you were to have an operation where you have lots and lots of CPT and you have lots and lots of money, and you can put, say, 10 or 15 cones in your truck, then obviously you get a wide range of cones. Because if you know that you are not dealing with soft soils, you're only dealing with the hard granular soils, now you may use your 15 centimeter square cone. But if you know that you're going to deal with soft soils, you may pick your 10 centimeter square cone. And if you are not so much worried about the values of your sleeve friction, if the tip resistance is the most important thing, you may pick your subtraction type cone. But for ones where you want to have accurate readings on your compression type, on your sleeve friction, you pick your compression type cone. That's great if you have this wide range of number of cones on your truck. But most of us don't have that luxury. Most of us have a very limited number of cones. And most of us are having to deal with the situation that you really don't know what soils you're going to get. Sometimes you may do a job where you have soft soils, sometimes not, but sometimes you don't even know whether you're going to deal with soft soils. Therefore, my recommendation is the following. Always use a piezo cone. Without a piezo cone, you cannot do the correction in cohesive soils as we saw before. Therefore, piezo cone, simple. Here, I would have probably a preference for the 15 centimeter square cone because you get deeper. And your sensitivity, try to get it back by using a compression type cone. Yeah, because that at least gives you an independent reading for your sleeve and your tip resistance, so a better chance that you're still going to get your measurements. And then if you are going to get a second cone, then go to the 10 centimeter square cone there as well. Similarly, if you then have a 10 centimeter square cone to deal with your sensitive soils, always go with a 10 centimeter square compression type cone. And in that case, you then can move from a 15 centimeter square cone, because that's what you want to have, the more sturdiness and the more robustness, make it even stronger, and go to then a 15 centimeter subtraction type cone. But the main thing is, there is no right answer that is always correct in all circumstances. The piezo cone, yeah, I don't see any reason why these days you would not use a piezo cone. But the other parts, there is this weighing of arguments. What is here? What is there? And therefore, what I put here in the bottom part is that it depends on the soil. But I would suggest compression in most cases, because since you don't know what kind of soil you have, at least with a compression cone, you do measure your friction sleeve accurately. But in the end, it's up to the user. It's something that you need to weigh, and there is no straightforward answer, unfortunately. To conclusion, well, in a way, it would not come as a big surprise. I could have started this presentation by saying, what is the right cone? Well, it depends. Now, there is no easy answer to say what is the right cone. What is important, though, and that is something that I want to push this webinar in a slightly different direction than what I've talked about so far, is that it's important that you understand the options, that you understand what you're trying to do. Because once you understand what you're trying to do, you understand what is the right cone, but also the right equipment to come to a job site, whether you need a 10-ton pusher or whether a 10-ton pusher, a 20-ton pusher is more appropriate, depending on how much force you actually need. So that understanding, that is really what is the most important thing, so that you can make the right decision for you. And that brings me back to what was mentioned at the very beginning by Troy. That is the whole purpose of this CPT webinar series, to give you a better understanding of what plays a role, what happens when you perform CPT, why you're performing CPT, so that you can make the right decisions. And with that, I've come to the end of this presentation. Right now, I don't think there are any questions, and I don't see anything in the chat box. So either well, there's a question coming up apparently. Somebody from Costa Rica. What is the best pushing rig and cone to start a CPT business? Difficult question. The best rig, it all depends on how much money you have. But reality is, and when you look at, and we can go to, let me go back to the very first slide. When you have a truck, you usually talk about an investment close to $500,000. If you have a new truck, if you have a used truck, it might be somewhat less. A crawler, a full-fledged box crawler, probably $250,000. But if you have a lightweight crawler, it is a lot less than $100,000. And for a lot of people, that is the bottom line, because you need to start generating your business. The drawback of a smaller unit, and we'll talk about it in the future probably some more, is that you need to place ground anchors, because a compact crawler does not have the same amount of weight whereby the dead weight of the vehicle can be used to create the reaction force. So you need to place the 4 ground anchors. So you have to weigh that. Less efficient, but a lot cheaper. Personally, if you get started, a compact crawler probably makes a lot of sense. And then I would say there are different options there. At least go then that you have your highest capacity pusher, your 20-ton pusher, because you're always short of pushing force. And the cost difference between a 13-ton and a 20-ton push compact crawler is really not that much. Go with a 20-ton compact crawler. When it comes to the cone, probably if you are not sure what you're going to do, I would get initially 2 cones anyhow, because you never, if you're on a job site and suddenly something breaks, you have a backup. I would then get a 15 centimeter square cone, subtraction type cone, that I would use for the rough, the stiff soil layers that I have to go through, and I would get a 10 centimeter square compression type cone, so I can do my measurements in sensitive soils. I have then a backup, and then I probably have the most, the widest range, and still use then my 36 millimeter rods. Another question that came up is, how do you charge for CPT testing? By and large, it is done by a lot of companies do it by the meter or by the foot. But of course, you still have your mope and demope cost. And quite often, especially in countries like here in the United States, if you have to travel quite some distance, that mope and demope may be substantial. Because let's face it, to push a cone takes you about 25 minutes, and then the mope and demope is a lot higher. But that's probably one of these topics for the future, where we talk about how you price a CPT pushing or CPT sounding. That may be a good topic for a future webinar. And with that, we've come to the bottom of the hour. I want to thank everybody for being here and to attend this webinar. As Troy said, it's hard to believe that this is already number 15, but we keep going, which should be no surprise. There's plenty to talk about these subject of CPT. With that, thank you very much. Look forward to seeing you in the future, and hopefully you'll be doing much more CPT work, or at least be interested enough to start doing CPT work based on these presentations. Thank you, and have a nice day.